Vanessa. It's great to be here, everybody. I hope you're having an awesome final day or two of summer. I'm going to go ahead and share my screen and tell you all about how you can increase time to mission, have a very fast time to mission, I should say, using AI by enabling your analysts, users, everybody who needs to have a conversation with their data and only seeing anything they're ever authorized to see. So let's get started. It's a funny thing. In the last 5 years, we've had an incredible growth in large language models. And the so-called generative AI has really taken the world by storm. It's exciting, the possibility of talking to the computer. There is a problem, though. It's one thing if you're trying to build an application with your own data set, but if you're talking about a traditional organization like a large enterprise or government organization or really anything where there are a lot of silos and there is a bit of a data sprawl in the back end, information spread across hundreds, if not thousands of applications, users today probably have trouble finding information. And that is a major factor in delaying their ability to create complete projects and finish their missions. Because if they can't find, so the question is, if the employee can't find information, how is your generative AI ever going to help? Well, I'm happy to tell you, SWIRL is an amazing solution, powerful solution that connects your enterprise generative AI to your internal sources so that everyone working on the mission can have a conversation with their data. Importantly, it's a secure conversation and it can be entirely inside your own environment, as I'm going to describe in a minute. But before we talk about some of the technical bits, what does a conversation with data really look like? Here's a conversation that I've had. And it starts with a question. It's very frequent, or I find it very much my days are driven by questions and follow-up questions. It's a very natural pattern for any business person or analyst who, is an expert in a particular area or topic or working on a specific project. So I start by engaging SWIRL. It's not a search form. I don't go to some UI. It looks like a conversation. Here you're seeing a UI, but it could be through almost anything, such as Microsoft Teams or iMessage or WhatsApp, whatever was appropriate. I start by asking a question saying, I'm trying to find information about SWIRL's cyber insurance policy coverage. Now, the Copilot, SWIRL Copilot, which creates an educated conversation about your data, it's going to clarify my intent, saying, what exactly do you mean? Generally cyber insurance or SWIRL's specific policy? I'm interested in SWIRL's policy. It immediately identifies the most likely repositories where I will find information, Outlook messages and OneDrive files. So I confirm that OneDrive is likely the place to look. And less than 1 minute later, I get the answer generated by, in this case, OpenAI GPT-4 via a RAG or Retrieval Augmented Generation, which means fetching the most relevant documents to the query, in this case, SWIRL Cyber Insurance Policy. And in fact, what we got back is the answer from the PDF that had the answers and was sitting in my OneDrive. You can see the citations at the bottom. SWIRL's coverage is $1 million for a variety of liabilities. There's also a nice paragraph here describing the limits of liability, such as the 250K limit for fund transfer fraud. It also summarizes the cost of the program and a variety of other things. Most importantly, there are citations so I can click on those and verify the information for myself. Now, that's not all a conversation does. It's not just question answer. Very often there's a follow-up question. So I actually had a few. I needed to know the policy effective date. So I determined that was February 9th, 2024. I then asked the AI to summarize everything I learned, and I could ask it to translate that into another language, write it out in bullet form or prose, write a longer report, a 15K word blog post. The full power of the LLM is combined with the power to search on your behalf using your credentials and tokens, and to retrieve insights and generate insights from your personal view of the world. It's your Outlook, your OneDrive, your ServiceNow, etc. Now, conversations are a great place to start, but sometimes there are complications, I like to say. Perhaps you're trying to answer questions from complex documents that were really intended for humans, not so much for LLMs. So here's an example of a 50-page PDF that covers maintenance for a particular piece of capital equipment. It's actually a maintenance item. And might ask the question, how long would it take to replace the vacuum pump filter on this? And how often should I do it? You get back the answer in 1 second from a table that, as you can see, would require me to look up the every 12,000 hour value across the columns and match that to cleaning visually. Swirl can actually help the LLM understand this, and it's from a PDF, much like a lot of other knowledge. So Swirl also is able to extract the relevant text and pass it to the AI for this analysis. So answering questions from complex documents, another massive time saver. I estimate that the Swirl cyber insurance policy mission probably would have taken me 10 minutes. This might have taken me considerably longer searching through the PDF once, of course, I had found it. But we don't only consume information that is in unstructured or content or text form. Very often the answers to our questions are in data. They're in metrics or so-called structured data. Swirl loves to query sources like that as well, from Postgres to cloud sources like Google BigQuery and data platforms like Snowflake. So here you can see natural language questions being answered by a data set, and Swirl actually generates these charts on the fly. It can also pass through charts that may come from other systems. So when I ask a question like how much did we ship by product category, I actually get a nice heat map there with I should say a scatter plot with the different categories of product. If I ask a question like how much funding was provided to different companies by category, I can quickly get that visualized for me so I don't have to pursue a data table or read a narrative, which wouldn't be appropriate for structured data. Of course, many questions and answers actually cut across both, combining text, content, and data and numeric values and visualizations of those. And with Swirl, as part of a conversation, you can get all of those. So let's talk for a minute. What does it look like to use Swirl? First of all, Swirl is installed in your environment. It's software, infrastructure software. It is not a hosted service. Second, and most importantly, it connects any LLM and virtually all your backend sources within whatever environment you install it. So it supports an air-gapped deployment. It supports deployment in your own hardware. I run it in Docker on a laptop. You can run it on Docker on any kind of cluster setup. It also comes with Kubernetes if you want to auto-scale it, etc., if you prefer that. Swirl doesn't require internet access. It implements a real-time architecture that only accesses data when the user makes a request. All requests are always made on behalf of an existing user. You're not picking up, bulk copying, or ETLing any data into a new repository that you then have to make sure you have the right permissions, aggregating the access control list, etc. None of that's required. You can't put documents into Swirl. Swirl makes use of your existing search APIs. That's the most important element, so that avoids the need to bulk transfer data. And it's always searching on behalf of the user who has an entitlement. If the user isn't authorized to see something, they will never know it's there. Swirl accelerates missions with over 100 integrations. For starters, connecting any of the LLMs and generative AIs on the left-hand side to all of the data platforms, enterprise applications, and web services that you see in the subsequent columns. Whether it's a old school keyword search engine like Solr, something newer like a Pinecone, a data cloud platform like BigQuery, Snowflake, whether it's a enterprise application like Asana, Atlassian, M365, Salesforce, or ServiceNow, or an information service in the cloud like OpenSanctions, Blockchain.com, Northern Light Research, or NewsData.io. All you have to do is configure it, you put your keys in, and everything just works. Your users can search across all these data platforms and also have a conversation. This is a key point. Architecturally, Swirl gives you the best of both worlds. For starters, you can have that ongoing dialogue with the AI, which is educated by Swirl as to what you're authorized to see. Again, I want to mention it can be omni-channel. You've seen some UI examples from us, but you could do that, have that same conversation in almost any channel that supports it, from Microsoft Teams again to iMessage or WhatsApp. When the user and the generative AI agree in the process of that conversation that there's a searchable target, some agreed on set of things to search, then Swirl fires up the search engine, goes out, hits all of those search endpoints using the configured information, such as, again, their credentials or obtaining the user's credentials via single sign-on, OAuth 2, and OpenID Connect. Then executes the search, gets the results back asynchronously, re-ranks the results, and then rags with the most relevant content so that you get back that insight, the answer to your question, the summary of the data, the comparison, whatever it is the user is trying to accomplish. That's the two-way layered model that SWIRL supports. A conversation with the generative AI that can help guide you to the right sources and ultimately select the perfect search for you, and then the execution of that search and the summarization of it, along with always the citations. So let's take a step back and talk just about re-ranking, because that really is the secret to SWIRL. If you don't move the data into a new repository and index it, how can you make sense and find the most relevant results across all those different sources that I mentioned? The answer is SWIRL's Reader large language model. The reader is critically important here. It is not a generative AI that creates text. It only understands text, can determine how similar phrases or sections of words are, extract entities, understand sentiment. It's all about understanding, not about generating text. It does not create text, so it does not hallucinate. What it does is it reads the results and re-ranks to find the most relevant. There's a great video on our website. You can check it out, but you can also try this right now online. If you search Google for Red Hat acquires, the top articles are all about IBM acquiring Red Hat. And in a paid search model, I guess those are the most popular or perhaps have been the most promoted articles. On the right-hand side of the slide, you can see if you run that same search through SWIRL, which actually comes out of the box with a Google programmable search engine, and we even give you the keys so you can try this with 2 lines of Docker. Just go to our website, swirlaiconnect.com, and give it a try. By the way, that edition is available through Apache license. If you want to start working with it right away, you can. But you'll see that SWIRL re-ranks the results, and results 7, 8, 9, 10, 11, 12, which are way below the fold, are brought to the top, re-ranked to the top. And that's because they're actually about what the user asked for. They are Red Hat acquiring companies, closing an acquisition, and even buying a company called Polymeda. This is the power of the Reader LLM. It knows that the user would prefer all 3 words together, that Red Hat's an entity, so it should be at the beginning of a sentence, and it knows that buys means the same thing as acquires. Ultimately, the secret to the Reader LLM is a combination of search, natural language, and AI or vector techniques. When the search query Red Hat acquires goes out, SWIRL gets back the JSON from Google and from many others, as an example. It then uses a re-ranking pipeline, which combines search features, things like stemming, the match window, proximity, negation, highlighting. It also uses the full power of vector math. So the query and results or slices of the results are all vectorized. And among other things, cosine similarity and other understanding algorithms in the Reader LLM are brought to bear, along with statistical measures like evidence and recency. So those produce a new score for each of the results that SWIRL gets back from all sources, and then SWIRL ultimately serves up the re-rank results, sorting by score descending. And that's really the core of SWIRL's Reader LLM. Interesting fact about it, you can actually plug in any set of embeddings. And the Reader LLM will understand as many languages as are supported by the embeddings that you plug in. A very important point, re-ranking is actually been shown to be the most effective method for information retrieval versus fully vectorizing data. This is a third-party study. You can see the URL down there. ZHub put a lot of effort into this. I'm not going to try to walk you through the whole thing here, but I'm going to show you essentially the results. So the idea, or the problem in this case, is to answer a natural language question with a paragraph. And so in this case, you can see at the bottom of the chart, it says number of documents retrieved. The documents are paragraphs. Okay, there's one natural language question. So the curves here are showing whether or not they were able to successfully answer each of these 3 approaches, was able to successfully answer or provide the right paragraph for that question. So if we take a look at the curve, the blue line is a so-called only vector embedding. So that's if you were to take the data, load it into a vector database, and use a vectorized search, meaning searching with an embedding or a vector, if you will. The orange line is BM25, which is so-called Boolean match 25, which is a naive keyword search engine like good old Solr, Elastic, or OpenSearch. By the way, all of those engines have uh, the ability to use vectors too. So I'm only talking about older versions that you wouldn't have upgraded. Now that you can see right away the vector database, the vector embedding approach, um, it's not as good necessarily at when you're only retrieving one paragraph, right? If you only retrieve one, well, you might be successful. It looks like about 65% of the time, both of those approaches were pretty good for one, meaning about 65%. You only retrieved one. What are the odds you're going to get it right the first time? But as we increase the number of documents, so if we retrieve 5 paragraphs and see if any of those match the query, you can see the vector database begins to pull away from the BM25, and it's considerably better when you pull back a typical number of search results, like 10. The study only shows 9, but you can see it's probably 2.5% better. The blue line is versus BM25. Now, the best line, though, is the yellow line. That's BM25 at 50, re-ranked with vector. What does that mean? Well, it means just getting a few more results from the naive search engine, meaning instead of getting 10 results from BM25, a naive search engine, we'll get 50 and then re-rank them with vector using SWIRL. That curve starts out better than either of the others and stays ahead consistently and is again about 2.5% better than vectors and about 5% overall better at 10 results than it is versus the naive search engine. And the reason for this is that you only get the benefits of vectorization if there are no results that are an exact match. So it's a long tail thing, and you can see that eventually, when you're retrieving enough, the vector ends up being the same. Right? It asymptotes with the BM25 re-ranking. SWIRL is this line, the yellow line. You don't need to move your data. You don't need to re-vectorize it. No vector database is required. It'll do a great job of querying your Elastic, OpenSearch, and also all applications that you might use, which may or may not have vectors. And it can retrieve those results and use vectors to find the best across all sources. So that's the secret of SWIRL. And it's the key to increasing the time, really getting fast time to mission. So let me cover a couple of use cases. SWIRL is used a lot in academia, and in particular, some of the more interesting applications are things like alumni portals, assistants for alumni that can help explain questions like when can I come for the reunion, question answering for students and faculty, when's the last day I can drop a class, source selection. If I'm trying to research a paper or maybe prepare for a test, how would I find information about Stokes' theorem? Could come back with the answer that here are many sources, some of which you might not even know you have access to as a student or researcher, and you can then dive right into those, either searching or having the AI search on your behalf. Another great example from the enterprise, self-service supply chain data. So this is a large global pharma company, and today their supply chain teams open a ticket and a data science team responds within 2 weeks to most questions that there is not already some report or dashboard that answers. And that's, as you might expect, a fairly expensive way to answer questions. Using SWIRL, they're able to answer questions using natural language and combine consume information both in text or content format from direct sources, from AIs that they have already deployed, and also from data systems. So they're able to really get structured and unstructured responses and even AI responses all in one place. Now, they actually did a study, which I just shared with you here, but ultimately the goal of self-service for this company was to empower colleagues, the data consumers who need to know. When they're authorized and need to know, they should be able to get the data without having to ask someone else to do the job. And that's really the goal of, in this case, deploying SWIRL. The results, 7.5 hours per week of savings for a new analyst. In this case, they have a model employee named Amanda. Amanda started, she's relatively young, new graduate, I should say, with just a few years of industry experience, dropped into a new position, has access to hundreds of information sources and no idea where to start for something simple like a project status report. But using SWIRL, she can have a conversation about which sources might be most appropriate. She's got all the skills to do the analysis. That's the getting started part. And from there, she's able to save a huge amount of time by not going from system to system and figuring out if that system is the magic answer. So I'm going to pause here and would love to take any questions. Uh, Hopefully that made some sense and inspired some approaches to speeding up mission times. And I'd love to see if we have any questions.
Hey Sid, we had one come through the chat. It said, so I can install Swirl in my own private cloud. What about a data center?
Absolutely right, anywhere. So Swirl is infrastructure software. You deploy it in your own environment. That can be anything, anywhere. Swirl does not require access to the internet, etc. Typically, people deploy with Docker or Kubernetes, but there are other options available as well. So no, absolutely can deploy it anywhere, including air-gapped environments. Swirl does not need to phone home. It does not need to access the internet, etc. Unless you configure it to do so, it will not. I see we have at least one more question.
Yeah. Does Swirl support air-gapped environments? What about GCC high and low?
Yep. So we do fully support air-gapped environments. You would install there. We are working away on a new offer, which will be in the Azure Gov Marketplace, and that offer will allow you to install in GCC low and high once it's gone through all the necessary approvals.
And then there was one more. How do I index documents into Swirl?
Got it. So I want to reemphasize that Swirl makes use of all of your existing indices, any search engine, application, or database that you have today. It doesn't accept new documents into it. You're going to want to access all the existing sources that you have and not create a new repository. If you want a new repository for new sources, that's not Swirl. I think the key point about maybe behind the question is, indexing and copying data is very costly and time consuming. The fastest route is to search and really be able to have a conversation with the data sources that you already use. And that's what Swirl is designed to do.
Alrighty. Well, I just wanted to take a moment to say thank you so much, Sid, for being our speaker for today. It was lovely getting to learn a little bit more about Swirl, and I'm sure everybody here agrees. And I hope that everyone here found that this webinar was informative and helpful to you and your organization.